streamer. Okay, so there are certain topics here that will kind of repeat over and over again, like the cisp versus risk issue. I will basically not really just spend half an hour, but only to talk about it. I will touch on that topic, from time to time. Okay, so so the scheduling here is not accurate. And then we're going to move on to the other part, which has to do with the syllabus. So this part is common to all of my classes. If you were in my CISP 440 class earlier today, or you came to the Tuesday, Thursday lecture, same stuff. Okay, but this is how I write my notes. Okay, so every single text that you need to read in this class is kind of in this format. There's the PDF version, and there's also the HTML version. I mean, you guys know what to do with the PDF version, but it is available, for those of you who like to print out stuff. You can put it into a binder. It just looks better, when it's printed out. I, for the most part, just use the HTML version. All right, so I'm going to skip the first part here. It's not going to be that important. My name is Tack. You can just call me Tack. You can call me Professor Tack. You can call me Dr. Tack. They all work, and it doesn't matter which way you want to do it. What just happened? Did I click on something? Okay. So anyway, my phone number is 484-8250. It is very unlikely that you will find me answering the phone. Because of all the office hours, I'm only going to be in my actual office in one of those days. Okay? But if you leave a message, whatever message you leave will become an MP3 file, and it will be emailed to me, to my Exchange account. So I'll still be able to hear you. I'll talk about what is the best way to contact me. This is not, okay? Phone is not the best way to contact me. Email is also not the best way to contact me. I mean, you can definitely do it that way. Face-to-face time, you can come to my office hour. I do have office hours from Monday to Friday. Monday, Wednesday is from 11 to noon. It's in the Design Hub. How many people here know about the Design Hub? Okay, so are you in the Design Hub as an intern right now, or you have just heard of it?
I heard you talk about it earlier today.
Oh, okay, gotcha. Okay, cool. So maybe one day I'll find someone who's actually an intern at the Design Hub to talk about the Design Hub. Basically, it's an opportunity for people to get an internship that works for the college. So you're not working off campus. You're not working on something that has nothing to do with programming. Okay, instead you'll be programming, you'll be coding, you'll be developing code, and it's on campus. It can potentially be paid as well. So you might be getting $11 per hour. You're working as an quote-unquote intern at the Design Hub. Okay, so it might be interesting to some of you. On Tuesdays, it is the same time, but the room is changed because there's a class in the Design Hub during that time. So it'll be in Tech Ed 309, which is also going to be the same room where the Computer Science Student Club will meet at noontime. So right after my office hour is the time for the student club. So if you want to hook up with students, mostly students who are maybe a few semesters ahead of you, that is a great way to meet with those students. They can share information about how to apply for colleges, how to apply for four-year universities, which one to go, how they compare, So it's a great way to kind of connect with those students. Okay, so they're typically, maybe two, semesters ahead of you. Some of those are almost ready to graduate. On Thursdays, which is tomorrow. Sorry. Tomorrow it is going to be in the afternoon from 4 to 5:30, 4:30 to 5:30. And this is the only one that is actually in my office, which is CMC 404. It's the building on that side, and my cubicle is the third one on the left-hand side. Once you get in, you can find my cubicle pretty easily. It's only so big. Okay, it's not a huge space. And then on Friday, it's online, and the time that I will be paying attention, through Canvas is from 11 to noon. So for the most part, it's right before noon. Are there any questions about this part? No questions? Okay, moving on. So presentation delivery method is a face-to-face class, so there's really not a whole lot to talk about. Your reading material will be provided through Canvas. Most of the links are already there. I might be adding some additional stuff throughout the semester, but for the most part, you can just download stuff, print it out, and study or read those documents. Regular effective contact. This is supposed to be contact and not content. I really should go fix it. So this section is mandatory to basically talk about, how I interact with my students. Okay, so in addition to being a face-to-face class, you can contact me or ask questions and interact with me through these different means. We talked about office hours already. We talked about email and phone. This is the best way to contact me, is to use the LMS or use the Canvas ability to message me. Because whatever you message me through Canvas will be sent to me also as an email. Okay, so that means, I will get to it pretty quickly. But it also leaves a trail of communication in the system, which is why the college prefers that way, because it is, if someone wants to audit ARC and say, okay, are your professors actually interacting with their students? Do they answer questions? Well, here's the trail, okay? So the student send out the text, message at this time, and the professor replies at this time, and so on. So they really want that trail of communication. Time frame policy, if it's a normal day, like a work day, it will take me up to 24 hours to reply to you. If it is a weekend or a holiday, like spring break, it might take me 2 days to get back to you. Etiquette policy, just common sense stuff, okay? Just don't do anything that can be perceived as hostile, as harassment, as discrimination, okay? If you have any doubt, just, kind of think about it a little bit more, okay? Cyberbullying, mostly apply to online classes, which this one is not. Spamming, content, okay, so typical stuff, just keep it civil. Is that good, or, okay, cool. First day of class, which is this one. Any absence of the first day of class or orientation is sufficient reason to get dropped, which means if you're physically in this classroom, you're good. If you're watching through the stream right now, you're not so okay. I really doubt anyone is doing that, because in order to know that this class is getting streamed, somebody must have taken a class from me already. But this is the same policy with all of my classes. So that person would have known that I will basically say, if you're not physically here on the first day of class, you'll be dropped. So I really doubt that anyone is watching it who's actually in the class. Now, that might be someone who is not in this class that is watching. That might happen. So
Just for fun.
Just for fun, yeah, exactly. Well, there might be someone who wants to kind of get a brush up of the material, but although in that case they wouldn't watch the first day of class. I mean, accommodations. If anyone needs has disability and need assistive technology or assistive help of any kind, contact the DSPS office. So the DSPS office has a phone number and also a TTY number, teletype number. So contact those people for additional help. And then in terms of excessive absence, the point is the district, not just the college, but the district defines 6% as excessive absence. So if somebody is absent 6% or more in a semester, that is called excessive. And the district basically says, if it's excessive, that person can be dropped from a class. So 6% amounts to, you can afford to have 2 absences that are not excused. So you can use, it can be for whatever reason, okay? Your car broke down, okay? Your alarm clock did not work. Okay, you woke up and it was not where you went to sleep. That might happen. You might get abducted by aliens. Okay, so basically, I'm not asking about why. Okay, you get two absences, for those particular reasons. So what can be excused? The third one is considered excessive. Okay, if I take roll and I find that somebody has 3 unexcused absences, that person can be dropped. So the question now is, what can be excused? The district says only sickness that is verified can be, has to be excused. Okay, so if you're sick, you have a doctor's note, you bring it to me, I do not have a choice to say that, nah, no, this cannot be excused. I have to take it as an excuse. But everything else is not, may not be accepted as an excuse. Okay. As I talked about this, in the morning, if you have jury duty, or if you have military exercise that you have to go to, that you're being called to go to a military exercise, those count as well. Okay, paintball or airsoft games do not count.
I'm guessing you've had that.
Huh?
I'm guessing you've had that before.
No, not yet.
It's always first.
So it has to come with verification and official paperwork, that shows that yes, you have to go in that case. So all of these are definitely not going to be automatically accepted as excuses. If it's once or twice, I would go like, okay, I'll let it go. If it's too frequent or becomes a pattern, I can choose not to accept these as excuses. So late policy is there's no late policy. Okay, if something is late, I'm not going to grade it. But most of the time, you have at least 1 week to work on your homework assignments. So just start early. If you encounter problems, contact me early on. Okay, you can just, like on the second day, you contact me and go like, okay, I'm really stuck with this. I need a lot of help. If half the class is encountering issues like that, then they go like, oh, maybe the assignment really is too difficult to be done in a week, so I will extend the deadline. Okay. But if it's on the last day and then go like, oh, I'm so behind, I cannot get this done, and there's only 1 or 2 people, then I cannot extend the deadline. Okay. The next section, 12, talks about academic dishonesty or integrity, depending on how you look at it. So basically, the bottom line is your score reflects your and only your academic performance. Okay, according to the limitations that I have imposed in those tests. So that's the bottom line. And the way I define dishonesty in the context of tests and homework assignment and stuff like that is when a student attempts to show possession of a level of competency, knowledge, or skill that is beyond the level of the student. Okay, any questions about this particular statement? In other words, the means is not what I focus on. Okay, I'm focusing on just the intent and the result of the action. If somebody is telepathic, okay, and they cheat by telepathy, it will still be considered cheating. Okay, even though it is not by copying somebody else's work and stuff like that. Is that making any sense? Now, how can I tell if it is telepathy? Mind meld? No, I look at the results. I look at the actual answers. Okay, if two people turn in answers that are wrong and they're uniquely wrong, and it's consistent across multiple questions, I don't really care how it is done. It is suspicious. Okay, and I will raise a flag. Okay, so if I raise a flag and I do not have any actual evidence, then I will basically ask those two students to take another test. Okay, another test that's based on the test that was that is in question. If both students answer that test and their scores are consistent, okay, and it's consistent not across the students and also with the test that is in question, then go like, okay, my bad, it's just completely freak coincidence, okay. But if there are inconsistencies, then I'll bring it to the dean, and then the dean will help me decide what to do with it. Is that okay? All right. So the importance part here has to do with if ARC or any college does not put any attention to, does not focus on academic honesty, then the grades really do not mean anything. And when that happens, whatever four-year university you transfer to, we just say, we're not going to take any ARC students because the grade doesn't mean anything. They can be graduating with a 4.0 GPA, but they are not prepared. Now, why do you think four-year universities would prefer not to take in students who are not ready, who are not going to succeed in the four-year university?
Because it reflects their own reputation?
It might ruin the reputation of the university, and also I think it affects their funding as well. Okay, so if the bottom line is money and funding. So that is the most immediate reason why academic honesty is important. Consequences, the whatever work is involved is probably the students who are being suspected will get a 0. But if I bring it to the dean's attention, the dean can basically point in a different direction, including getting the discipline officer involved in those cases. It's very seldom that I really have to do anything like this, okay? But it's nice to kind of have it all spelled out. If someone is falsely accused, what is that person going to do? Well, that person can start with reading the Guide to Student Rights and Responsibilities, because it will tell you how you can file a grievance. If you are accused of cheating in a class, but you really did not do anything, okay? What can you possibly do about that situation? This link will link you to a document that discusses the entire process, okay? Who to contact on campus and what you can do about it. It is important, okay? Because I really need this to be a fair process, okay? If I accuse somebody, that person has to have a way to counter and say, no, I did not do that, okay? Is that making any sense? Okay. So classroom behavior and stuff like that. The bottom line is, this is a learning and / teaching environment. I just do not want any distractions or interruptions or disruptions, okay? That's the bottom line. If this is too late of the day, you haven't had dinner yet, your blood sugar is running too low, and you doze off, it's okay. It does not bother me. If you snore, and the next person says, I can't hear what the professor is saying, then I might wake you up and go like, hey, you might want to sleep somewhere else because of the snoring. But if you're not snoring, you're not distracting anybody else, I go like, okay, it's not a problem. It's not a problem. To me, it is not a disrespect. Just because somebody is dozing off in class. Why? Because I have done a lot of that. So I understand the physical fatigue at the end of the day. Many of you have to work, you have family, and so on and so forth. So if you feel tired, I can understand it. And if you want me to wake you up, you can let me know too. Does anyone want me to wake you up in case you fall asleep in class? Okay.
Use my head for target practice.
Well, but these days I don't have chalks anymore, right? I cannot just go like, like in the good old days. Cool. Okay, so mobile devices, easy. You just set up do not disturb on Android devices. pretty sure the iOS has a similar feature. So all you do is you set up this block of time on your calendar, and then you link do not disturb to that calendar, and just say that if there's a scheduled quote unquote busy block of time, turned off ringing and all kinds of stuff like that. I set it on my phone. The nice thing about doing this is the phone will automatically re-enable ringing and all the other stuff at the end of the class. So you don't have to remember to turn it back on. All right. There's no eating or drinking in the classroom, but since in this particular class you don't have a school computer in front of you, it's okay to drink plain water. Okay, so if you want to bring in a bottle of water, that's fine, not a problem. Coffee, not okay. Soft drink, not okay, but plain water is okay. So if you need to stay awake, okay, and you say, caffeinated water, it doesn't taste good, I'm pretty sure they make those pills with caffeine and other quote-unquote energy components, so you can just take a pill and swallow it. Do they make patches? Like nicotine patches, except it's caffeine? I'm pretty sure they do.
It might. That's weird.
It might be expensive. Go to Think Geek. Okay, if it is available, it's going to be over there.
Sky Mall moves or something?
Yeah, I'm pretty sure they make it. Now I have to find out. Caffeine. Okay, I cannot spell it, but Google can help. Patch. Yep,
Oh my God,
apparently they do.
Walmart, right? And they sells it at Walmart.
Yep. Yeah, but Amazon has it too. Store pickup. And the closest one is where?
Well, that one's closing,
It's
so.
like 2 minutes away.
If you can hurry.
Well, if Walmart has it, Target may have it too. So, cool. So, I'm not against that. In fact, I might go get some myself. Cool. Excellent. Found something new. Oh, nope. Wrong tab. Where am I here? No, that's not the one. Uh-oh. I lost track.
Holy moly.
Too many tabs. There we go. Okay, got it.
3 Wikipedia pages.
Yeah, this is what happens when you're... This is also what happens when I learn a new programming language, or a new programming environment. There'll be like 20, 30 tabs to the point where I cannot... There's no text left on each tab. How to attend lectures? I'm going to lecture you on how to attend lectures, because the way I do lecturing is a little bit different. Okay, first of all, I stream the lecture directly to YouTube. Okay, which means as long as the technology is working, which means it may not be a bad idea to check with me and just say, okay, are we recording? Can we check? Just kind of check with me a few times. But since it's being recorded, it means you don't have to write down every single word that I say, because the audio is also getting recorded. It also means that if I type some test code on the screen, you don't have to frantically copy everything because it's recorded. Okay, so you can focus on understanding the ideas, okay, understanding the concepts, okay, and see if you understand everything. If there are certain things you go like, I'm not really quite sure about that, use your energy to think of the question to ask. Raise your hand and then just go like, okay, about that thing over there, I'm not understanding 100%. Can you re-explain da 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 da? Okay, instead of frantically copying everything and not really processing it. Okay. Which also means it may not be a bad idea. Once we get into the content stuff, it may not be a bad idea to write down the time when I talk about a particular concept, or at least when I transition from one to another concept, because that will allow you to fast forward in the recording to about the time where okay, I just need to revisit the definition of blah blah blah. Okay, you look up your own notes and you find out that okay, we talked about that at 7:45. Okay, so you can skip the first 45 minutes of the video, so you can get pretty close to that topic without having to watch the entire thing. Okay, so that might be helpful. Let's see, how to succeed in this class. Okay, so this class is about the way I do grading, or the kind of questions that I ask in the exams and the final exam. They're all about being able to, you have to show me not only that you get the knowledge, but you also know how to apply the knowledge and problem solve. So it's about the application of what you're learning. It is not about just regurgitating what you have learned. Is that okay? So I put a lot of focus on problem solving. So, which also starts here, problem solving starts with understanding the concepts, okay? So how do you know, in your own mind, how do you know whether you are understanding a particular concept or not? Go ahead.
If you can explain it to someone else.
Okay, see if you can explain it to somebody else, or is it consistent with the explanation of other people? So it is kind of tricky. Sometimes you may think that you understand the concept correctly, but it turns out to be not entirely correct. Okay, so I'll give you activities as well. Okay, so the activities should help you kind of validate whether your understanding is correct or not. Okay, it depends on the person. Some people kind of have the innate ability to kind of find discrepancies of stuff. Okay, so in your mind, you will go like, okay, I think da 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 da, but that's not consistent with blah blah blah, something else that you have observed. That is a flag your brain or your mind is waving. Go like, hey, your understanding of this concept may not be 100%. You might want to clarify with the professor. So whenever that happens, just kind of raise your hand, let me know, ask questions. Okay? It is very important to ask questions in my classes. So this section talks about what is exactly understanding and how to do that understanding. Okay, so there's a gibberish sentence here, and I'm just using it as an example of how to analyze a particular sentence. Okay, there are things that you can identify here that you already know. Okay, the word becomes, okay, everybody knows that. When, okay, everybody knows that one, and is followed by a perfect tense, everybody knows what that means as well. So even though there are some really kind of icky, funny words here and here and here, the sentence structure itself is usually understood in this case. So now the question is, how do we understand this particular sentence? What do you ask? Okay, so you ask about the things that you do not know. What is a bujadi? Okay, what is the action of modifying something? Okay, what is muffaced? So those are the words that you have to focus on and go like, okay, what is the actual definition of that? So there will be cases in this class where we'll introduce terms, and then you have to kind of really make sure that you understand those terms. All right, so moving on. Okay, if you know that you're not understanding a particular concept, what do you do? If it happens, if you have that realization in the class during a lecture, what do you do?
Ask for help.
Ask for help, exactly. Okay, how do you ask for help?
Go to office hours.
Go to office hours, or you can just ask questions during the class. Now, a lot of people kind of hesitate to do that, because they think about what other people, look at me. Okay, so let's say I have a question. So some people may say, well, I don't want to ask the question because the rest of the class, maybe I'm the only person who's not understanding. So other people may look at me and say that I'm dumb and whatnot. Okay, I would say don't let that stop you. Okay, even if that is what is in the minds of other people, ask the question because it is for your own benefit. Okay. But the truth is, if you have that question and you are working hard, you're really trying your best to understand the material, you're doing all the homework assignments, you're reading ahead of time, the chances are, if you're not understanding, half the class is not understanding either. So by asking the question, instead of being considered, oh, other people are judging me, well, they are judging you. They're thinking that you are the hero of the class. They're all thinking, Thank goodness somebody asked a question. Okay? I'm not sure whether that's true with other classes. With my classes, that's usually the case. So don't hesitate to ask questions. If I ever appears to be intimidating, or critical when people ask questions, let me know, because that is not my intention, and I will learn how not to convey that wrong message. Is that okay? All right. Do I sound intimidating right now? No, not yet. Huh? Okay.
You're wearing a Doctor Who shirt. I don't think you can be intimidating.
Well, I'm also a big fan of Darth Vader.
Uh-oh. Hallway scene.
I like that scene where he force choked somebody, and then he looked down and go like, "Apologies accepted." That was one of my favorite. And the other favorite scene of Darth Vader was not Han Solo. Who's the administrator of the Sky City? Londo? No.
Lando.
Yeah. So when he was complaining, go like, "But that was not what we agreed to. I'm supposed to keep these guys, and you're taking everybody captive." And Darth Vader said, what did he say? He said, "Perhaps you think you have not been treated fairly." That was it. Yeah, those were my favorite lines from Vader.
The deal has been altered. Don't pray it does not get changed again, altered again.
Yep, and then he was on the Death Star, kind of overlooking the progress of the Death Star, and then the captain goes like, "Yeah, we're doing okay," and then Vader said, "Well, the Emperor may not be pleased." Well, something to that effect. Yeah, those were like favorite lines of mine from Darth Vader.
My favorite line is, "I hate sand. It's coarse and coarse and gets everywhere."
Yeah, I think he's a very misunderstood character. This is what middle management will do to anyone.
Turn him into Darth Vader.
You're stuck with the stormtroopers, who are kind of incompetent, and you have a demanding boss, okay, who's just not doing a single thing himself, right? So you're stuck with all the work and no one to actually do the work. Anyone would turn into Darth Vader in that situation. So
it's the actual plot. It's the actual story.
Yep. Okay, problem solving. So how do you do problem solving? So you can read all of this, the detail, on your own. So we talk about, practicing is important, so that's why you will have homework assignments. When you do the homework assignments, there are some homework assignments that are not graded. Now those are really important, because the ones that are not graded, you guys can work in groups. Okay? Find a few buddies in this class if you want to. Okay? If you want to go solo, that's fine too. Okay? I'm not going to dictate, how you're going to work on the ungraded assignments. But if you find a few buddies and go like, okay, let's work on this together, it's okay, because it's not graded. You will not be, if there's no consideration of, oh, did someone cheat? Nope, you guys can all work together. Okay, out of a group of 5 people, one person can be doing all the work, the other 4 are deadbeat. I don't care. Okay, the person who's doing all the work can just fire the rest of the team and go like, you guys are not helping, go away. Okay, but the important part is, since I'm talking about independence, is when do you ask other people for help? That's the question. Do you ask like 5 minutes into the homework assignment, you cannot proceed, you go like, okay, I'm giving up. 20 minutes and so on. There was a really good answer this morning. Okay, somebody in the earlier class today in 440 said, if you wake up 3 times and you cannot, you're not making any progress, then it's a good time to ask someone. So basically, you're giving yourself enough time to digest the question, to digest the problem that you're supposed to solve, to think of the tools that you have already learned, the knowledge that you have already gained, and you're still not making the connections. Okay, so that typically translates to 2 to 3 days for most people. So in 2 to 3 days, if you're not making any headway whatsoever, okay, you're not going anywhere, then it's a good time to ask. Okay, I know the threshold is different for everybody. I'm not saying that everybody will have a threshold of 3 days, like, I give you a homework assignment, I will not answer any questions about that homework assignment until day 3. I'm not going to do that, okay? If you have questions on the same day, go ahead, ask questions, not a problem. It's just really a recommendation so that you give yourself enough time to think about something. Because if you come up with the solution, if you come up with the connection, it's going to stay with you. If you ask somebody else and that other person just kind of gives you the answer, that's not going to stick. At least that's my own experience. Okay, everything that I really understand by thinking about it and just taking time to absorb the concept is still with me. Things that I just ask somebody else, it's like, what is that thing? How does it relate to this? Okay, I lose track of that stuff pretty quickly. All right. So what applies to me does not necessarily apply to everybody else. So you guys have to kind of think about a strategy to succeed in this class. I can only make recommendations based on what I know, which is about myself, right? Because I'm not you, I cannot tell what is the best strategy for you. All right, so getting to the really good stuff here, grading, right? So in grading, everybody knows, there's A, B, C, D, F, as your final letter grade for the class. So the way I look at A, B, C, D, F, okay, short description, excellent, good, satisfactory / fair, low pass, and fail. Okay, those are the words that most universities use to describe the GPA, the 4 points in the GPA. Okay, if you ask me what is the worst possible grade somebody can get in the class, in this class, classes that I teach, which one do you think is the worst?
C.
Yep. C. A grade of C is the worst grade to get out of a class. Why? You probably have the answer already.
Because it lowers your GPA. I don't know.
It has nothing to do with GPA.
Oh, because you get the least out of the class.
Yep.
Also, if you get a C, you're probably not going to retake it, so you're going to move on with that certain limited amount of knowledge.
Yep.
Exactly.
And then what happens in the next class?
You're
It's going
behind.
to be harder.
You're already behind on day 1. So it's going to be an uphill battle, which also means the next class, that person is likely to get another C or fail. Okay? But isn't a D and F even worse than the C? No. A D and an F simply means that you cannot yet show me that you have sufficient understanding and the ability to apply the knowledge that you're supposed to learn in this class. Does that mean I'm going to look at you and go like, oh, you're a failing student? No. Okay, there are a gazillion reasons why people may get a grade of D or F. Okay, you may be sick, maybe family members are sick during that semester. You got other things to do. I have people with getting kicked out of an apartment and so on and so forth. There are a gazillion reasons why someone may be getting a failing grade. So what do? Just take the class again. Okay. A and B, I'm not worried, okay, because anyone who can get an A or a B in the class typically has shown enough understanding or the ability and the ability to apply that knowledge already. So I'm fairly confident those people are ready for the next class. D and F, take the class again, okay, no big deal. C means, you're just, that person is just barely getting by in this class. So any other classes that depends on the knowledge of this class, it's kind of iffy, okay? That person has a, how should I put it? The chances of succeeding in the next class is lower, okay? So that's the way I see it. You can disagree. I think it's okay to disagree with most things in this class, except for the really black and white stuff, okay, which is about logic, okay, about math and stuff like that. So if you want to read this part, it's okay, because I use job evaluation and product evaluation to kind of talk about what is an A, B, C, D, F, in those particular situations, so that you guys have a better understanding of what I see as an A, what I see as a B, and so on. Now, because I grade all the exams and all the parts of answers of an exam using this method, so that's why I can also use this method to assign letter grades. If at the end of the semester, the point values that you get is at least 87.5%, that's an A. Okay? If it's somewhere between 62.5% and 87.5%, that's a B. If it's anywhere between 37.5% and 62.5%, that's a C. It only takes 37.5% to get a C in this class. Okay? And D and Fs are basically just lower than that.
Any of the work.
Huh?
D's and F's are only if you didn't even bother to do any of the work.
Well, a D can be the result of not really understanding the material, not knowing how to take a class from me. It does not always reflect the person is not putting in the effort. It can be the effort is not put in an effective manner. Okay, so I'm not going to judge people if they get a D or F. As I said, there can be a gazillion reasons why they're getting a D or an F. But that's the percentage. And it's doing this again. Computer is alive. And Meltdown. I'm pretty sure I just updated this one, so. Okay. Oh, talking about Meltdown. Why do you think this class has anything to do with Meltdown? Or Specter, for that matter?
Because it's a processor exploit?
It's a processor hardware exploit, okay? And that's, now we are not going to get to the point where we will talk about caching mechanisms or look ahead, pipelines and stuff like that. So we're not going to get to the advanced topics that actually led to the discovery of those particular bugs in the processor. But this class does form the first level foundation of what you need to know in order to understand how those exploits work. Okay? Why is that important? What is the significance of Meltdown and Specter? Why are they different from the ransomware that we have been talking about in the past? Yep.
Because they're hardware exploits, not software.
Yep, they're hardware exploits, which also means they work across all operating systems. Okay, Linux is not safe, Mac OS X is not safe, Windows is not safe. And it's not really just Intel platforms either. Some of the ARM architectures are also susceptible. In the case of Spectre, AMD processors are also susceptible.
90% of processors are AMD too.
Yep.
So we're screwed.
Well, that's why we have to patch, okay? But the patch is likely to decrease the performance of the processor because you have to stop the race condition, which means you have to make one side always lose the race, okay? So that makes it, kind of, we have to decrease the performance of your system to make it more secure. Okay, so this class, does give you the foundation of a few more classes. You will need a few more classes, to really understand Meltdown. At least 100%. But this class will get you started with those, with that understanding. Why is that important? I mean, Meltdown is already discovered and fixed. It's a closed book, right? So there's no importance, to understand those concepts anymore.
Just because it's been discovered doesn't mean that there's more problems we haven't noticed yet.
Exactly. And the significance of these problems, as you said, is a hardware problem. So it doesn't matter what operating system you're running. It does not matter. Okay. Now in the 440 class, I gave people a pretty grim, look of the future, where everything is automated. Okay. You have self-driving cars. It's becoming reality. It's not even 2020 yet. The big rigs are going to be, self-driving. Okay, because both Tesla, Cummins, and a few other companies are already working on electric and fully autonomous self-driving big rigs, okay, semis. The military has attack drones that are automated. Okay, there's no person, in a control room, flying those things. They can maintain radio silence, during the entire mission. Okay, so all of these things are happening. So I would say in 20 years, okay, this is just my projection. In 20 years, most things will then be automated. And then somebody finds another version of the Meltdown, vulnerability. What's going to happen, when 90% of stuff is susceptible to such exploits? When the exploit is discovered, it's time to go back to the farm with a shotgun, because your potatoes is worth gold. I'm not kidding. I mean, think about that scenario, okay? Because the power grid is controlled by computers, okay? Water supply controlled by computers, and so on and so forth. So if somebody can disrupt, by exploiting these hardware issues, they can stop just about everything. And that's the day that I don't want to live to see, but that's also why computer security is going to be super important, because we are putting more and more things to become automated. All right, so that kind of gives you an idea of what kind of careers you might want to consider in your future.
Farmer.
With a shotgun.
Yes, exactly.
That's gunsmithing.
You might also need to landmine the perimeter of your farm too.
Explosives.
No, I didn't say the mechanism, but you might want to mine it. Yep, because if anyone who can actually produce food and have access to fresh water is going to be sorted after. Let's just say. Okay, activities. Graded homework assignments are worth about 20% of your grade, which is what we're going to do after this class. So at 8:30 in the lab, I think it's 409.
Yeah.
Yep. So that's what we'll be doing. So that will contribute to the 20%. The first exam is about 1/3 through the semester. That's worth another 20%. The second exam, which is about 2/3 through the semester, is worth another 20%. And then the final exam at the end of the semester is worth 40% of the grade. So that's how the grades are distributed. Any questions about this part? No questions? Well, that's pretty much the entire syllabus, because I talked about ungraded assignments already. I just haven't really talked about how you can how ungraded assignment is going to help you. It's going to help you because just by doing the ungraded assignment is already helping. That is how studying should be done in this class, at least in my opinion. Okay, reading the material is not going to be that helpful. Okay, but by actually doing problem solving and actually doing the homework assignment, that is the bulk of how you learn in this class. Okay. With every single ungraded assignment, I will give you the solution. Okay, I'll give you my solution. So the first thing you can do, or should do, is to compare your solution to my solution. They may not be the same. It's okay. Okay, because there may be solution A and solution B. They both solve the problem, and they're both correct. That's entirely possible. But at least you will know your correct solution. I will also give you test cases. In other words, if you present this as the input, that should become the output. If you present this as the input, that should be the output. So this way you can test your own solution and validate and see whether your solution, as far as the tests can do, can validate whether it is correct or not. What if it passes all of these tests, but at the back of your mind, you just go like, I'm still not convinced that my solution is 100% correct, because there might be some test cases that I have not given to you, and those actually may review that your solution is not 100% correct. So what do you do when you have that doubt and go like, I'm not 100% that my solution is right. It's different from yours, even though it passes all the tests that I can give it. What do? You ask me. Okay? Use the lab time. Show me your solution, and then you can ask me, is this, still correct even though it's different from yours? Okay? Go to my office hours. Okay? Send me an email with an attachment of your solution and ask me, okay, is this okay? Is this 100% correct? Is that okay? So this is how you can gain from ungraded homework assignments, because the only difference between a graded and ungraded assignment in this case is whether it counts to your score or not, counts to your grade or not. But this also, makes it possible, once again, for you guys to work in groups, which I think helps more than just working alone, by yourselves. So you might want to use the lab time to network a little bit, just so that you can find out, who in class may be a good candidate to work with you, okay, throughout the semester. You don't have to do it today, just at some point, if you want to, you guys can form teams to work on these ungraded assignments. And that probably will become your study group. Okay, so before the exams, you might want to sit down and study, quote unquote, study together. So you can ask each other questions, okay, and check your understanding. All right, so are there any questions before I continue with actual course content? No questions? Okay, cool. I brought up this page in the other class, and I'm going to bring it up here as well. It's about the MBTI, or Myers-Briggs type indicator. The I stands for indicator. You can go to a particular website. This is the one that I use myself. It's called 16personalities.com, which is really cool. Because by answering about 50 questions, it won't take you a whole lot of time. Okay, for an average person, it might take you maybe 10 minutes, to answer all of these questions. But it will basically assign you to one of the 16 personalities, and there are 16 of those, because each personality has 4 letters. Okay, INTP is one of the personality. The I so I means introverted. E means extroverted, so they're opposing qualities. The second letter is N versus S. N is intuitive, and S stands for sensing. Okay. The third letter is T versus F, thinking versus feeling. The last letter is P versus J, perceiving versus judging. And because each letter has 2 options, and there are 4 of these, so 2 to the power of 4 is 16, and that's why it's called 16 personalities. Okay? So once you take the test, this particular website is pretty good, because they don't just say that, oh, you are INTP. They actually will tell you how much you're leaning to, in my case, to introverted, how much I'm leaning to intuitive, how much I'm leaning to thinking, and how much I'm leaning to perceiving. So it's a percentage. It's not just a hard number. Go like, oh, you're perceiving. Nope, it would actually tell you, are you kind of like, somewhere close to the middle, you're 60% perceiving, or are you all the way over, like 90% perceiving. So when you combine that with properties of each personality types, I'm not going to pick my own. You can read about my personality. I'm just going to pick something that I'm definitely not. Okay, I'm definitely opposite to many of these types here. Or the sentinels. Yeah, this would be almost, this is the entire opposite of me. Okay, let's read about this one. So anyone who's tested ESFJ, it will tell you about many things. So I'm not going to read the actual text, but it will, if you look at the left-hand side, you can see how it will analyze the strengths and weaknesses of people of that particular type. Romantic relationships. Okay, you can read about it if you're interested. It's not important in this class. Friendships, nah. Parenthood, nah. Career paths, that might be useful. Okay. Now, what if computer science or code development is not on your personality type? don't get discouraged. Okay, it's just those are just suggestions. Workplace habits, can be useful. Okay, especially for those of you who are already in the workforce. Okay, this will tell you something about yourself. But just the second one is already really helpful because you might be able to use this to refine your study habits. I'm easily distracted. Okay, so to counter that, my study habits would be basically, okay, I need to go to a quiet place. Okay, I need to focus. I'll put a timer. Until the timer dings, I'm not gonna go onto the internet and search for something. Okay, or something along that line. So I find myself, I myself, find the MBTI, quite useful. Okay, it is not required, but if you're interested, you can take the test. It's free. Okay, they do ask for your email address to send you the most detailed analysis of your personality type. So you can just go to Google, sign up for a new account just for this purpose if you don't want to get spammed. I don't think they will spam you, but if you're careful, just sign up for a new account just for this purpose. I'll give you one example of how this is useful. About 3 semesters ago, there was a student in cisp310 who was not doing very well in that class, despite her effort, despite coming to my office hours, to try to clarify concepts. She got a D out of the class. Okay, and she took the personality test, as a part of doing what I say. Okay, you might want to do this. And then last semester, I met this student again. And then she approached me and go like, "Thanks, Dr. Tech." And I go like, "Well, here comes the sarcasm." But that's not what she did. She was actually thanking me for, 1, failing her, and 2, introducing the personality test. Because she failed the class, she was really just kind of thinking, should I continue as a computer science major? Because it cast some doubt in her mind. The second thing was, her personality test, kind of pointed her to careers that are kind of more in the business, because she's more people-oriented. So she changed her major to business with an emphasis on MIS, Management Information Systems. And then she said she could not be happier because of the change. Now, I'm not saying this is a typical case. It is a sample of 1. Okay, so so the standard deviation is undefined. Okay, so you took some statistics classes, right? Because if you have a sample of 1, the standard deviation cannot be defined. But I'm just telling you what happened. Okay, actual stories. All right. So, as you can see, I kind of digress sometimes, a lot of times. Cool. All right. So, if there are no additional questions, we're going to go into the content stuff. Are there any questions? No questions? All right. So the first actual slide that I'm going to go over is this one. It's called Physical States, Truth, Numbers, and Computers. So the way I'm teaching this class is to give you a complete picture, starting with physical states. Okay? So physical states, in computer science, is actually not that important. Okay? How your computer, what type of quantity your computer is, or what type of physical quantities your computer operates on is really not that important, but it becomes a basis for this particular class. So we'll start with electromechanical computers. So an electromechanical computer is basically something that is at least partially mechanical, but the mechanical part is there to do the switching of the electrical current. Is that okay? Does everybody understand what is a relay, like an automotive relay or electrical device as a relay? Is that okay? All right. What does a relay do? Describe it to me.
passes things along a series of nodes.
Okay, it's a switch basically,
Yeah.
right? So a relay can be seen as a switch. Okay, well, so are those things along the wall next to the door. Those are switches too. So what differentiates a relay from a normal switch that we flip? What turns on a relay, and how do you turn on a relay? How do you change the state of a relay?
By giving it different power levels?
Yeah.
Electrical power, right? Okay. So you apply electrical current to control another electrical current. That is the key. Okay? Whatever physical quantity, whatever physical state you use to control the device in return is controlling that for something else. That is the key of a relay. And electromechanical computers are kind of like that. You can make a computer out of relays, by the way. The first really famous electromechanical computer is the bomb computer. How many people have watched The Imitation Game? Really? Okay. Maybe I should make it a homework assignment. Because in that movie, okay, they showed Alan Turing working on the bomb computer in various stages. Okay, and it's definitely an electromechanical device because you can actually see mechanical mechanisms, clicking and turning and stuff like that. Okay, what is the significance of that particular computer? What is the bomb computer used for? Yep.
Crack Enigma.
To crack the enigma, and what is the enigma? The German encryption device. Okay, it looks like has about the same size as a typewriter. So whatever key you type, okay, it will translate that through a series of disks to something else. So even though the radio wave is a broadcast signal, in other words, the British can intercept the transmissions, but they will just be receiving gibberish, okay, because the letters are all mapped all over the place. They're not randomized, but they are dispersed. Okay, so unless you have another Enigma machine using the same setup to decipher the message, you can intercept communications all day long, but they do not make any sense. Okay, Alan Turing, he also contributed manual methods for cracking the encryption. But the manual methods became infeasible because the Germans introduced an additional disk to the whole setup. So the number of combinations that you have to test through became a lot more. It is not like that it is impossible to crack the encryption. It is just that by the time you crack the encryption, the information is useless. There's no value in the information anymore. And that's why they automate the whole process. This started the whole thing about automation, because the bomb computer is basically an automated version of the manual method to crack the encryption. Okay? So that's the significance, historical significance of the electromechanical computer. And then we have vacuum tubes. Okay, vacuum tubes. For those of you who are interested, you can read the rest. You can also right-click on the links here to kind of understand how a vacuum tube works, and also what a triode is, because a triode basically forms the most basic components of a computer that is made up of vacuum tubes. It is basically a relay, except it is not mechanical. You use a particular electrical current to control another electrical current. So from the abstract level, it is just like a relay. But from the physical perspective, there's no mechanical components. And without without any mechanical components, what is gained?
Speed.
Speed, exactly. It is the same comparison between a traditional hard drive versus an SSD. Why is an SSD so much faster compared to an equivalent or mechanical hard drive of the same price?
Because it doesn't need to speed up. It just is on.
There are two aspects, but you're correct. Go ahead.
There's no arm to the hard drive's limited to how fast, physics, how fast the disks And the
Yep.
splatters can spin and the
Yeah.
Exactly.
solid state drive isn't.
Yep. Want to add to that too? Nope. Okay.
You know, just like when you turn on the computer, it has to go through the entire system and then all the way back. That's why it takes so long. While an SSD, you turn it on and just boop, it's on.
Well, it's not just when you turn it on. During the operation of your computer, you have to access various parts of the hard drive, right? So with a mechanical hard drive, it has to move the disk head from one track to another track. That takes a lot of time because it takes, if the average amount of time is what, 8, 10 milliseconds now, okay? You might have like super fast mechanical hard drive that can get it down to like 7 milliseconds, okay? But the order of magnitude does not change. It is still measured in multiple milliseconds. 1 millisecond is 1,000th of a second. Once you get to the right track, you have to wait again because the sector that you want to read may not be right under the disk head at the time. So now you have to wait for the sector to rotate until it is right under the head. So there are two mechanical delays because a hard drive is a mechanical device. But SSD doesn't have to do any of that. Okay, it's completely electronic. There are no physical components to move, and that's why it is so much faster. And for that same reason, vacuum tube-based computers are much faster than mechanical/electric computers because there are no moving parts. Okay. All right. So moving along. So the bottom line here is the first famous computer that is vacuum tube based is called the Colossus, and the Colossus is also used to decipher encrypted communication, but this time it is not the Enigma machine. It is called the Lorenz cipher. The Lorenz cipher is a huge big device. It is not portable, so that's why it is only used by the headquarters of Nazi Germany. It is too big to be carried around to the field. But because it is a big encryption machine, the encryption is also much harder to crack. And as a result, you need a faster computer to crack that encryption. So moving ahead, we are now moving on to transistors, which your Pentium processors has. Okay, we really have not advanced much beyond transistors. Okay. Yes, they're much smaller now than before, okay, because we're down to what? How many nanometers? Does anyone know the current generation of I series Intel processor? What is the size of each transistor? 14? Okay.
Nanometers? 14 nanometers?
14 nanometers, okay, which is really small because it was just, let's see, I would say about 30 years ago. Okay, about 30 years ago, people got transistors down to almost a micron, which is 1,000 nanometer. Okay, and they thought that this is it. Okay, we cannot get transistors any smaller when they hit 1,000 nanometers. And then today, 30 years later, we have transistors all the way down to 14 nanometers. Yep, and that's why computers are getting faster. They're consuming less energy to get the same amount of work done, and they're also much smaller as well because you don't have to dissipate the heat, which also limits how much space is needed for your computer. Is that okay? All right, cool. So when we talk about transistors, okay, now it becomes important to talk about the types of transistors. We'll talk about that later. The next one talks about physical states. So in the case of transistors, we are dealing with electrical. You can look at it as current. You can look at it as charge. Okay, so I would just look at it as charge, because current is charge that is moving. Okay, so everything actually boils down to electrical charge, and that's how current computers work on is electrical charge. Okay, can you stop the flow of electrical charge? You're dealing with a switch, okay? But what actuates the switch? The flow of electrical charge, or just electrical charge itself. So that's basically what we are dealing with. So we are still talking about some physical state that can be measured. So in this case, it can be visualized using a voltmeter. How many people have taken some class from electronic technology, ET? So you're familiar with a voltmeter or even maybe oscilloscope. So those are machines or instruments that can help you, measure and visualize electrical charge, current, and stuff like that. Okay. So that's what we're dealing with when we're talking about transistors. Okay, you go to Fry's, you go buy a transistor. It is physical. You can actually pick it up, right? You can make a circuit board out of it. It is physical. And then you look at how you use those transistors. Okay, you can use a voltmeter to look at, oh, I wonder whether this pin has a high voltage or low voltage. You can actually measure that, right? It's all physical. When we talk about programming, it's abstract. Okay, we're dealing with quote unquote truth. Okay, so if you remember from cisp310 or 360, okay, did you guys talk about the conjunction operator, which is also known as the AND operator? Okay, or not. Okay, so those are the operators that you already know. What do they work with? What is the type on either side of those operators? It's called a Boolean, right? So what is the special property of a Boolean variable or a Boolean value? True or false? Okay, so how do we get from physical state? What is the charge at this pin? Okay, is it a high voltage or low voltage? How do we get there to whether something is true or false? That's the first question. Okay. So next we talk about transistors, and this is actually a part of your lab. So by talking about this for just 5 minutes, it should help a little bit with your lab. Okay, so there are two types of transistors. One type is called AND transistors. So with an AND transistor, a transistor has 3 pins. Okay, the 3 pins this is the gate. The gate is always the one that's pointing perpendicular to the other 2 pins. Okay. The other 2 pins, one is called a drain and one is called a source. And guess which direction the arrow is drawn? Okay? One is called the source, the other one is called the drain. Which way do you think is the logical way to draw the arrow?
Source.
From source to drain. It points to the drain, correct. Okay.
The direction.
So in this particular picture, this is the source. Okay, it is where the arrow is originating from. This is the drain, which is where the arrow is pointing to. Is that okay? An N transistor does not have a bubble here. Okay, a P transistor does. The bubble means negation. So how do we turn on an N transistor when the input or the gate is not negated? So the way we usually understand stuff is if there's a presence of something, it's on. If there's a absence of something, it's off, right? Since this is not negated, it basically means if you have a presence of electrical charge at the gate, the transistor is on. What does it mean when the transistor is on? What does that mean? A transistor is a switch, right? So when a transistor is on, the switch is in a closed position, which also means it is connecting from source to drain. Is that okay? What if there's no electrical charge at the gate? The absence of a charge turns it off, which basically means this is not connected anymore. The source is no longer connected to the drain. You just flip the switch off. Is that okay? So basically, it really is just a switch, except you use electrical charge to determine whether it's on or off, whether it's connecting or not. So the next one is what we call a P transistor. Look at this picture here. It looks almost exactly like an N transistor.
Except it's in the opposite direction.
Exactly. Well, okay, the direction thing we can just flip, right? But there's one thing that we cannot just flip and make it the same. It's the bubble. The bubble means negation, which also means in this particular case, the lack of a charge means it is on. The presence of a charge means it is off. It is the opposite of an N transistor. But what does not change is it is still pointing from source to drain. When the transistor is off, the source is not connected to drain. When the transistor is on, then the source is connected to drain. Yep.
So its orientation being opposite is irrelevant?
Not exactly. It is irrelevant for this particular discussion.
Okay.
Yep. So we still do okay so far with the differentiation between an N transistor versus a P transistor. Okay. And we have 2 minutes left in the lecture, but I think, if I just kind of push a little bit, this is a good use of our time, because you will see this again in the activity that you'll be doing at 8:30. So I might as well explain what it is now, so it makes your job a little bit easier when you're actually doing the activity. Okay, so this is a circuit. Okay, it's a circuit with 4 transistors. There are 2. What are these again? Are they P or N? P. They're P transistors, and these are N transistors. Okay, and you can see how the arrows are kind of opposite. It's significant. A P transistor can only have the source attached to positive voltage. An N transistor can only have the source connected to ground, or what we call negative or 0 volt. Okay, that's just the rule of the game. Okay. So when you look at this picture, you go like, okay, that looks kind of funky, because whatever is connected to the gate of Q1 is also connected to Q3. Whatever connects to the gate of Q2 is also connected to the gate of Q4. So basically, they come in quote-unquote pairs. So now the question is, what happens when X is 0 and Y is 1? Now, I'm basically saying a 0 is the absence of a charge, and then 1 is the presence of a charge, voltage. Okay? What do you think is going to happen? So you basically have to emulate and go like, oh, let's see. If X is 0, or the absence of a charge, then it's going to turn on Q1. Q1 is now connecting the source to the drain, which also means this positive voltage is now connected through Q1 to the output pin. So the output pin will now experience the same charge as this voltage here. Is that making any sense? What about these 2 transistors? X is a 0, so Q3 is off. It is not connecting. What about Q4? Because Y is a 1, so that would turn on Q4. Well, you have one switch that is on and one switch that is off, but these 2 switches are connected in series, which also means, is this ground voltage going to be sensed by the output pin?
No.
No, because if 2 switches are in series, if you turn off at least one of them, the whole thing becomes disconnected. But what about this guy? It's also off because Q2 is connected to Y, and Y is a high 1. There's a presence of charge, so that would turn off a P transistor, which Q2 is. But isn't that going to disconnect the output pin from the high voltage? No, because Q1 and Q2 are connected in parallel. Okay, when a circuit is connected in parallel, when switches are configured that way, if at least one switch is connecting, the whole thing connects. Is that making any sense? So now we have a scenario where, hey, we can kind of play this game, and how many possible combinations can we get out of this picture? How many ways can we configure the input and output voltages and observe the output? Let's say each one can either be a 0 or 1.
And that's 4.
There are 4 of them. Very good, because 2 to the power of 2 is 4. So we can actually spell this entire thing out. We can emulate this and spell out this entire thing. And that turns out to be known as a negated AND gate, otherwise known as a NAND gate. Okay? For those of you who buy SSDs and flash memory and stuff like that, that should be a familiar term, right?
Yeah.
So a NAND gate, this is a NAND 2 gate, which means it has 2 inputs. Okay, NAND 2 means it has 2 inputs. Does that map to any actual operator that you learned from C or C++? No. It maps to 2 operators because you're doing a negation after a conjunction. So you go like, thanks a lot. Okay, we just introduced something that is totally not connected to concepts that you have already learned. Right? Not really. I'm going to finish this here because it is kind of significant to go all the way to the end and go like, okay, so let's say we have NAND. How do we, oh, by the way, this thing here, this is the symbol used to represent NAND, the negator of a conjunction. So negation, which I use this symbol for, is really just the negation of x is x NAND x. Okay? Now, I'm not going to verify that here, at this point. This is the symbol for conjunction. X and y is really x NAND y, NAND x NAND y. And then the last one is OR. X or y is really x NAND x, NAND y NAND y. In other words, if you just give me a lot of little NAND gates, I can reproduce negation, conjunction, and disjunction. Everything that you are familiar with, I can make those out of NAND gates. Is that okay? That's the significance. I'm not going to show you the math or the Boolean algebra yet, okay, because we are running out of time. But I do want to get to this point because the connection is important. What did we talk about at the beginning of this class, not the syllabus, right after the syllabus? What did we talk about? We talked about electromechanical devices. We talked about vacuum tubes. We talked about transistors. Things that you can buy, you can touch, you can put into a circuit, you can solder and stuff like that. Then we talk about physical quantities, okay? Electrical charge, current, things they can measure and visualize using instruments, okay? Voltmeters, oscilloscopes, and so on. Now we are talking about Boolean operators, and they're all connected. Now the actual details of the connection is kind of tedious, okay? That's a lot of work. But the bigger picture is the more important one. It's basically saying, if you give me transistors, I know how to make these logical operators work. Okay? So I'm going to let that end today's class, but you really need to read this entire document and really understand the mechanisms and how everything connects. Okay? And on top of that, read the next one too, because we have 5 days before Monday. So read the next document as well. You don't have to fully understand it, because I'm going to talk about it on Monday. But if you read ahead of time, then it becomes a lot easier for you to absorb the information on Monday.
This is on Canvas, right?
This is all on Canvas. And if I go back to the Canvas page, I can just point out exactly where you find it. So this is just what we talked about today. Go ahead and read the next one. Okay, this one and the next one, which talks about base conversion, binary numbers, and stuff like that. All right, I'll see you guys in a few minutes. Okay, since I end the class a little bit late, I'll give you back those times, and then I'll see you at in room 409.
Going on a pilgrimage, you guys.